Alright, we're now on section 4.5, which is using the derivative and the second derivative to describe the shapes of the graphs of certain types of functions. And problem 198 in section 4.5 asks, why do you need continuity for the first derivative test? So before I jump right into that particular question, let's look at the first derivative test. And the first step that you want to do for the first derivative step is to find the critical numbers. And to do this, where does the derivative go to 0 for the x values in the domain, or where does the derivative not exist? Does not exist. So I'll just do this conceptually. I'm not going to actually input a function here, but I'll take a look at a function like this, let's say. And right here, we'll call this critical number 1, and over here, we'll call this critical number 2. So here, the critical numbers are x equals c1 and c2. And here we can see that by inspection, the reason I chose those is because the value of the derivative is 0 at those locations. So the tangent line has a slope of 0. So let's say that we had some actual function f. We took the derivative, we set it equal to 0, and we found some numbers c1 and c2 to find the critical numbers. Here we could, for an assumption, pretend this is a polynomial, and so the derivative always exists for all the real numbers here. And so the next step you want to do is, once you've found the critical numbers, you want to test on either side of the critical numbers. Test around, I'll just say the CIs, because you could have more than one critical number. So I'll make a number line, put C1 and C2. And what you're doing is you're testing the value of the derivative. So for between C1 and C2, I'll look at that. And between C1 and C2, the function is decreasing. So it's decreasing, therefore the slope is negative here. So the derivative is less than 0. So in here, f prime of x is less than 0. If you want to, you can call it negative. Okay. On the other hand, let's say for greater than C2, here the slope is positive, positive, positive. So here the sign of the derivative is positive. So on this side of C2 to the right, this is bigger than 0. Or we can say it's positive. On the other hand, if we go to the left of C1, decreasing, 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 decreasing over here. And so the slope here, it's increasing, increasing here, increasing here. The slope is positive on this side. My apologies there. And so notice that the value of the derivative changes sign here. It goes from positive, increasing, 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 to negative slope. And over here it goes from decreasing, 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 to increasing, increasing, increasing. So when the sign of the derivative switches from positive to negative, I'm going to have a local max. And when the sign of the derivative switches from negative to positive, I'm going to have a local min. Of course, this requires that the function itself is continuous, and what I've drawn here is a continuous function. So why do we need continuity? Well, I could have a different function, and I'll make something up like this, where I'll have the sign of the derivative actually alternate sign, but I won't have a local max or local min. So we could have something like, let's say we'll just be really simple, like that, and I'll put a closed dot there. And then I'll have something like an open dot, and oops, chasing myself around here. Sorry about that. Sometimes happens with this touchpad, it's really sensitive. So here I've got doing something like this. And I'll just call this, come on, C1. So I've got my critical numbers here, and it looks like the derivative goes to 0 around C1. So I'll try to make this stay put. Okay, get rid of that. Okay, so I'll make my number line here. Here's my C1. What on earth is going on over here? Okay, so here's my C1. And on this side here, the derivative is increasing, 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 increasing. So the derivative must be positive here. So here f prime of x is bigger than 0, so it's positive. No idea what is going on here. Positive here on this side. And on the other side, it's decreasing, 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 decreasing. And so the derivative is less than 0 or negative. Now notice across the critical number, the derivative switches sign. So here, positive to negative, so that would suggest I'd have a local maximum. At C1, f of C1, but notice this point, C1, f of C1 is not a local maximum. And so I need continuity for the first derivative test to actually work. If I don't have that, I could have a changing of the sign of the derivative about some critical number and yet not have a critical or a local maximum and a local minimum. All right, that concludes that, and we are done.